Hey everybody, happy Monday. Hopefully you are all completed with your acid and base test from last Friday. Just as a heads up, we're going to actually do a mini unit this week. It's called redox. Usually this unit is done as a complete unit over 2 weeks. We're actually going to just do part of the unit over a 4-day period. So today, tomorrow, Wednesday, you'll have some notes. Thursday, you'll have a couple practice problems to do on loose leaf and then a quiz after. There are no new skill checks this week, so please make sure that you are watching the videos. And as I said, a quiz on Thursday. It's going to be a short quiz, probably about 10 questions, but you'll get 2 attempts at it. And then after this week, we're going to be starting a project over the next few weeks, which I'll explain next week. So what you'll need for this is you're going to need your reference table out. You need your reference table out to the periodic table of elements. So you don't actually need it for any new tables. You just need it to be able to look at elements and especially their oxidation numbers. And either you can write your notes on loose leaf paper, or I posted the note packet where it says Unit 14 Redox folder, and then there's a notes folder within there that you can always print the notes at home if you would like. All right, so today we're going to do page 3 of your notes, which talks about oxidation numbers. And as I said, this whole unit is called redox. Now, what does redox mean? Well, tomorrow and the day after, we'll get a little bit more in depth with what that actually means. But redox reactions, which is a shortened for reduction oxidation reactions, are reactions that involve the transfer of electrons. So when we were doing acids and bases, we were talking about protons. When we were talking about the Bronsted-Lowry theory, redox reactions have to do with our electrons, which remember are negative subatomic particles. Both reduction and oxidation must happen simultaneously, meaning you cannot have one without the other. They happen at the same time. It's not like you can have reduction and no oxidation, or oxidation and no reduction. And as I said, you'll learn more what redox means tomorrow and on Wednesday as well. But today what we're going to do is we're going to practice assigning oxidation numbers. So I took this little picture from your periodic table of the element lithium, and when we talk about oxidation numbers are those numbers in the upper right-hand corner. Some elements have more than one. Some have positive oxidation numbers. Some have negative oxidation numbers. Do not try to guess oxidation numbers. Always look on your reference table. So as a recap, what I mean by oxidation number is an oxidation number is the charge of one atom of an element. So for example, with the lithium, the charge of one atom of lithium is +1. Remember when we write compounds, the positive element is always written first, or the cation, and the negative element is written second or last. This goes for polyatomics as well. If you have a positive polyatomic ion, that's written first. If it's negative, it's written second. And remember, your polyatomic ions are located on table E. Now we're going to go through a couple of rules about assigning oxidation numbers. Some are more important than others. I'll kind of point those out as we go. Always check the oxidation numbers on your periodic table. That's going to be the most helpful. So please have that out in front of you. So here's our first rule. In a compound, the sum, meaning if you add all the charges, is 0. And I'll give you kind of an example of that. So let's say that I have the compound potassium permanganate. The total charge of everything in this compound has to be 0. Meaning everything has to add up to be 0. It all has to balance out. Notice there's no charge anywhere in here. Each individual atom has its own charge, but all of them must add up to be 0. Our second rule, in a polyatomic ion, remember an ion is a charged particle. The sum of the charges is not equal to 0. It's actually equal to the total charge on the ion. Remember, your polyatomic ions are located on reference table E. For example, sulfate, which is SO4 with a -2 charge. Sorry, that all mixes together. SO4 minus 2. All the charges in SO4 have to add up to be negative 2. Not 0, because you can see this negative 2 right there tells us that all the charges from the sulfurs and the oxygens have to add up to be negative 2. Same thing with nitrate, NO3 with a minus 1 charge. All of the charges from the atoms in that polyatomic ion need to add up to be negative 1. And I can tell that here. Notice I don't have charge in KMNO4. There's nothing written in the upper right-hand corner, so the charge is 0. But for your ions from table E, the sum of those has to be negative 1. All right, rule number 3, the oxidation number of any element in what we refer to as the free state, meaning it's by itself, is always 0. So for example, if you see copper by itself, it's not in a compound, it's just sitting there, it's not combined, it has a charge of 0. This is what we call a monoatomic element. It does not come as a pair. Your diatomic elements, such as Brinkelhoff, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, those all come as a pair. So for example, if you see Cl2 by itself, that also has a charge of 0. Diatomic elements by themselves, uncombined, also have a charge of 0. So if it's uncombined, sitting by itself, the charge is 0. All right, number 4. What I need you to do is go to group 1. Group 1 is the first column on your periodic table, and take a look at all of the elements and their oxidation numbers in group 1. Except for hydrogen, they all have a charge of +1. So in group 1, they all have a charge of +1 if they're in a compound. So sodium chloride, for example, sodium would be +1. If you had potassium bromide, potassium's group 1, it'd be a +1 charge. Same thing goes for group 2 metals. If you take a look at all your group 2 metals, they have a charge of +2. For example, calcium. If calcium is in a compound with fluorine, its charge is +2. Same thing would go for magnesium chloride. Its charge is +2 because it's group 2. And you can see that just by looking at the upper right-hand corner for magnesium or for calcium. In a compound, fluorine, if you take a look at fluorine on your periodic table, it has -1. That's the only possible oxidation number it has. So fluorine is always -1. So for example, in the compound HF, fluorine is -1 in that compound. Now we're going to get into some more complicated ones. I'm going to be honest with you. The exceptions you don't have to worry about. I'm going to kind of go over them, but don't worry about kind of these little asterisks right here. Focus more on the main component. So for 7, it says in a compound, hydrogen is usually, and if you look at hydrogen, its possible oxidation numbers are +1 or -1. Hydrogen, for our case, is going to be +1 all the time. For example, in the compound H2O, hydrogen is +1. There is an exception, and that is something called a metal hydride. A metal hydride is when you have hydrogen with a group 1 or 2 metal. As I said, don't really worry about it. That is when hydrogen would have a charge of -1. But for your case, we're going to treat hydrogen as being +1. And then our last rule. In a compound, oxygen is usually -2. That's what you want to remember. There are some exceptions. We'll go over the first example, though. So in this example, oxygen has a charge of -2. I just wrote the charge in. There are some exceptions, as I said. If it's with fluorine, it's actually +2. And in a peroxide, which has this general formula, it's -1. But don't worry about it. Just use what oxygen's oxidation number is on your reference table. Now, that's a lot of rules. You don't have to memorize these. Use your reference table to help you. The ones that you're really going to want to remember are 1, 2, and 3. because you need to make sure you know that in a compound, the charge is 0. In a polyatomic ion, the charges are equal to whatever the ion's charge is, and that if something's by itself, it's always 0. You can't do that by just looking on the reference table. All the other rules you can figure out just by looking at the oxidation numbers in the upper right-hand corner. What we're going to do now is we're going to have some practice assigning oxidation numbers to each element within an ion or a compound. And I'm going to kind of show you how we go about this. So my first example is SO4, and then this charge right here, -2. That -2 does not go with the oxygen. That -2 is for the whole ion. So I like to rewrite this and put parentheses and put a -2 on the outside. So I know that that -2 does not go with the oxygen. They're not being nice. They're not giving you the charge. Okay. So if I want to know the charge of sulfur and the charge of oxygen in here, first of all, I know everything has to add up to be -2 because this is an ion. So they have to all add up to be -2. Now, if you take a look at sulfur on your periodic table and look at the oxidation numbers, it has 3 choices. It's either -2, +4, or +6. So that's kind of tricky because it's got more than one oxidation number. If the element has more than one oxidation number, you're going to put an X for its oxidation number. So sulfur, for instance, it has more than one possibility, so we don't know which one that could be yet. Take a look at oxygen. If you look at oxygen's oxidation number, it's -2. There's only one choice, so I'm going to put -2. If there's only one choice, you're going to put that as the oxidation number. Now what I do, I need to figure out what the charge of sulfur is. So I'm going to put a 1 here. That's because I only have one sulfur. I take a look at my oxygen. I have 4 of them. So I'm going to do this, X times 1, which is just X, plus -2 times 4, because I have 4 oxygens, each with a -2 charge, is -8. So X plus -8 has to equal -2. If I solve for X, I get X equals +6. So that means sulfur's charge is +6. Oxygen's charge is -2. There's always going to be one X and one oxidation number that you already know. So in this example, the X was the sulfur. The X is always going to be the one that has more than one possibility. The -2 is the oxygen because it only has one choice. Let's do another one. I'm going to clear this right now. All right, let's try NO3 with a -1. This is an ion. Remember, this -1 does not go with the oxygen. It's for the whole thing, so I'm going to rewrite this. All right. What this tells me is that the charge of everything, the nitrogens and the 3 oxygen, has to equal -1. All right, let's figure out, is the nitrogen going to be the X or is the oxygen? Take a look at nitrogen. Look at its oxidation numbers. There's about 8 of them on there. That's a lot. I don't know how to figure that one out, so that's my X. So the element that has more than one oxidation number is going to be your X. Take a look at oxygen. Its oxidation number, it's only one choice, which is -2. So from there, I can figure out what nitrogen is. I have 1 nitrogen. That's because my subscript is 1. So I have 1 nitrogen with a charge that I don't know, so that's X. Plus, I have 3 oxygens, each with a charge of -2. So that's a total of -6. And I know that when I add that 1 nitrogen to that -6 oxygen charges, it has to be -1. So I'm going to solve. I'm going to add 6. So I get X equals +5. So this means nitrogen's charge is +5 and oxygen's is -2. Be careful, oxygen's charge or oxidation number is not -6. It's -2. You just happen to have 3 of them. All right, let's try 2 more. So these two were both ions. So our first two examples were ions. Notice they had charges in the upper right-hand corner. If you look at 3 and 4, there's no charges in the upper right-hand corner. Now what that tells me is that all of the atoms added together are going to give me a charge of 0 when they're all added up. So I'm going to rewrite this to give me more room. All right, I know the sum of all these charges is going to be 0. All right, so let's start looking. Let's start with potassium. Take a look at potassium. It has a charge of +1, and that's the only choice. So I'm going to write +1. I don't have to worry about what it is because it's just +1. If I take a look at Mn, it's either +2, +3, +4, or +7. Since it's got more than one choice, its oxidation number is going to be represented by X right now, and that's what we're going to solve for. Take a look at oxygen. Its only oxidation number is -2. All right, so I already know potassium's oxidation number, +1. I know oxygen's -2, but manganese is the one I'm trying to figure out. So if they asked you to find all of them, you're going to find all of them. In this case, I want to know each element. Okay, so I have 1 potassium with a charge of +1. I have 1 manganese with a charge of, I don't know. So plus X, plus, I have 4 oxygens, each with a charge of -2. That's -8. And I know the sum of everything in that compound has to be equal to 0. So I've got 1 plus X plus -8 equals 0. -8 plus 1, that is going to be -7. So X minus 7 equals 0. To solve for X, I add to each side, and I get +7. So that means the charge of X is +7. So manganese's charge is +7. You'll get better at doing these in your head. Like, I'm pretty good at just going, okay, +1, -8, so that's -7. So this has to be +7 to balance out to 0. You'll get better at doing them in your head. All right, and the last one, MgClO4 2. This is a challenge one. So this, I'm not going to give you the hard one like this on your test. Actually, let's not even make it that hard. We'll make it challenging. Let's try it out. So I know this all has to sum up to be 0. I won't give you one like this on your quiz, I promise. This is going to be a challenge one. So I know the whole sum of everything has to be equal to 0. Now what's probably throwing you off is that you have parentheses and then you've got something outside. Remember, the parentheses, the subscript outside applies to everything inside. So I can actually rewrite this as Mg. This subscript inside is 1, so 2 times 1 is 2. Cl2, 4 times 2 is 8, O8. I can rewrite it that way. All right, now it just becomes like our other problem. Take a look at magnesium. It's in group 2, its charge is +2. So +2. I take a look at chlorine. There's 4 different charges. So I'm going to put an X for chlorine because I don't know what that is yet. And then oxygen is -2. So I already know magnesium is +2. I know oxygen's charge is -2. It's really the chlorine that I have to solve for. All right, and they all have to add up all the charges to 0. So magnesium has a subscript of 1. 2 times 1 is 2, plus X times 2 is 2X, plus -2 times 8, which is -16. All right, so let's combine. 2 minus 16, that's -14. If I add 14 to both sides, I get 2x equals 14, and if I divide by 2, I get x equals +7. Perfect. So that means chlorine's charge is +7. So if you're ever asked to find the oxidation number, and there's more than one for a specific element, this is the process you have to go through. You put the ones that you do know that only have one choice, and then you solve for the one that has more than one possibility. Remember, if they are ions, they add up to be the charge listed in the upper right-hand corner. This is not being nice and telling you the charge of oxygen. It helps to put parentheses around it to kind of solidify that. And then if it's atoms, these add up to be 0. You're not going to have skill checks on this, so you're going to want to make sure you write this down. You will have a couple questions like this on your quiz, which will be on Thursday. Please let me know if you have any issues. Take your time. Bye.